Hello friends, welcome to SV Union High School and Junior College, Pune. Standard 8 Mathematics. Chapter 6 Factorization of Algebraic Expressions. Let's start with rational algebraic expressions. Practice set 6.4. Hello friends, welcome to Standard 8 Maths, Chapter 6, Factorization of Algebraic Expressions. We are going to start with practice set 6.4 and we are going to learn to simplify the rational algebraic expressions. Now what is a rational algebraic expression? If there are two algebraic expressions given A and B, then A upon B is the form of rational algebraic expressions. Is that clear? So let us simplify the given algebraic expression here, which is a rational algebraic expression. You can see m square minus n square upon m plus n the whole square is in the form A upon B. And we are going to multiply this rational algebraic expression multiplied with another rational expression m square plus mn plus n square upon m cube minus n cube. Now we are going to use the operation multiplication and we are going to multiply the first rational algebraic expression with the second by simplifying it. But how to simplify them, these rational algebraic expressions? Now you have already learned many formulae and many factors of various algebraic expressions like a plus b the whole square, a minus b the whole square, a square minus b square. Then you have also learned about a cube plus b cube, a cube minus b cube. You have also learned the expansion of a plus b the whole cube, a minus b the whole cube. So all those algebraic formulae which you have learned, we are going to use those algebraic formulae and simplify these algebraic expressions or factorize these algebraic expressions and then use those factors to simplify the given rational algebraic expressions. So let us start with it now. So first example, we have simplified m square minus n square upon m plus n the whole square multiplied by m square plus mn plus n square upon m cube minus n cube. Now here let us start simplifying, but we need to find out the factors of the given algebraic expression separately. So let us start with the first one here. I am going to write it on the right hand side of the board. First is m square minus n square. Now you all can see that this is in the form of a square minus b square, and you all know the formula a square minus b square is equal to a plus b into a minus b, right? So I can now use the form of a square minus b square for m square minus n square. So m square minus n square will be equal to m plus n into m minus n. So now I have got two factors for the first algebraic expression. Let us do the same for the second one in the denominator here. What is it? It is m plus n the whole square. That is equal. This is in the form of a plus b the whole square. Now I know, and you all know the formula of a plus b the whole square. What is the expansion formula? I know that it is a plus b into a plus b, which was later on multiplied. Binomial multiplied by another binomial will gave us another formula a square plus 2ab plus b square, isn't it? So let me use the multiply a binomial with another binomial and get this form, get the formula, get the factors or expansion formula in this form, that is m square plus 2mn plus n here is n square, right? So I have got here two factors I have already got, so I may use either this form or I may use this form of expansion. Is that clear? So let us see which one we can use. Now let us see the third one here. Multiply m square minus n square upon m plus n, the whole square is multiplied by m square plus mn plus n square. Now this expression we can leave it as it is, because here we have m square plus n square, the middle term is mn. I don't think you have learned any expansion formula or factorization formula for such expression, so we will leave it as it is. So let us take the denominator expression now, m cube minus n cube. So m cube minus n cube is in the form of a cube minus b cube, isn't it? Yeah, so that is equal to you have already learned the expansion of a cube minus b cube as a minus b into a square plus ab plus b square, right? So let us use the formula and expand. M cube minus n cube is equal to m the whole cube minus n the whole cube, that is equal to m minus n into m square plus a into b is m into n plus n square, right? So I factorize and use the expansion formula is being used to find out and use those find out the factors of the algebraic expressions, and now we are going to use those factors or the expanded form to simplify the rational algebraic expression m square minus n square. I have already got two factors over here, so let me substitute them. Write the factors of m square minus n square as m plus n into m minus n upon, let me take m plus n the whole square, these two factors, so m plus n into m plus n. I am going to use those factors there, multiply by, write the whole expression as it is, m square plus mn plus n square. Remember, this is a whole one single expression because we have plus sign in the center, so it is a full expression, complete single expression upon m cube minus n cube. I can write this into, use these factors, m minus n into m square plus mn plus n square, right? So here I have used the factors. Now let me of these algebraic expressions. Now let me simplify this. Now these factors are in the form of a upon b, numerator upon denominator form. Okay, so now I can simplify by cancelling the like terms if they are found in the numerator and denominator. So here first one is m plus n. Here in the numerator, the same type of expression, a factor, I can see m plus n in the denominator, so I can cancel it. Okay, nothing but 1 into n plus n and 1 into n plus n is what cancelled here. So next step is m minus n. I don't have it here, but there is a like term on the other side. There is a multiplication sign. So when there is a multiplication sign, I can consider numerator and denominator and cancel the like terms m minus n. The same way, m square plus mn plus n square upon n square plus mn plus n square are like terms here. I can cancel both these terms. And now, what about this? Now, m plus n don't have any like term on in the numerator, so we don't have any other way to simplify it. So we will keep it as it is. We get 1. Now, how did we get 1? There is no term, no expression, no factor in the numerator. That doesn't mean it is 0. It should be considered as 1. Unit 1 will always be there upon m plus n. It is there in the denominator. So this will be my answer because I don't have any other way to simplify this expression. So this is this will be my answer here. So therefore I get m square minus n square upon m plus n whole square multiplied by m square plus mn plus n square upon m cube minus n cube is equal to 1 upon m plus n. So I have got the answer over here. I have simplified the first example of practice set 6.4. Thank you.